This section of the course, my friends, please, is named K-complexes and slow waves. In this first video, entitled What is a K-complex, I'm going to first start talking about a specific type of wave that we see mostly in N2 sleep. And later, I'm going to talk about slow waves that are basically the same thing but appear continuously in N3 sleep. In the next videos of this section, we will use Python and YASA to detect these waves, look at their features, and also learn how to visualize slow waves. Please, my dear friends, let's first see what a K-complex is. As I mentioned in the introduction of this course, the K-complex was first described by Loomis, and he called it a positive, negative, positive wave. So this spatial shape is one of the main features that makes the K-complex different from other sleep waves. It was also known from the very beginning that the amplitude of the K-complex is largest on frontal cortex. So for example, if we have a topography of K-complexes, the largest amplitude of the K-complex will be observed at the frontal electrodes, and it will diminish when we go backward. So when we move from the front of the head toward the back, the wave becomes smaller and smaller. And this has made many researchers say that the main source of this wave is probably higher order brain regions. For example, frontal areas, which are higher order regions of the brain, compared to sensory or lower level areas. It was also very interesting that even in those early days, they noticed that when a short sound was played, so for example in the bedroom, this wave suddenly appeared. So for example, a simple sound like someone knocking on the door would trigger a K-complex. So in fact, some people say that this K comes from the word knocking the door. Interesting, right? Now let's draw one example of this specific wave and talk about its features. Okay, consider that we are looking at the EEG and suddenly we see something like this, which would be called a K-complex. As you can see, this wave has a clear positive and also a negative peak. And finally, it returns to the baseline. So here we have baseline EEG and suddenly a negative and a positive wave. Depending on the montage, it may change. So for example, you might see a positive, then a negative wave. Please, my friends, as you know, frequency means the number of peaks per second. And here the frequency is usually below 2 Hertz. So the frequency of the K-complex is below 2 Hertz and lasts less than half a second. So the duration will be less than half a second. If we consider the duration and amplitude less than 2 Hertz, and again, it appears largest in the frontal areas. It has a very sharp shape, and it clearly stands out from the background activity. So overall, a K-complex is a sharp negative wave that is immediately followed by a positive wave, lasts about half a second, and it shows its maximum amplitude in the frontal electrodes. Another thing that is good to know is that this wave does not show much difference between the two hemispheres. So for example, if we have again our topography and we are comparing, for example, the K-complex in the left and in the right hemisphere, there's not that much difference between the two hemispheres. For example, if you look at electrodes C3 and C4 here, their shape and their amplitude are very similar, and there's no strong asymmetry between the two hemispheres. Now let me add something to our wave here. Let me just plot another wave. So again, we have a K-complex, negative, positive. I'm going to add another wave with another color here. You can see it has a high frequency component and appears on top of the wave. And this fast activity is around 12 to 16 hertz, 11 to 16 hertz, and you have probably guessed that this is the A spindle. In many cases, my friends, when a K complex happens, a third component is reported in studies, and this is spindle that appears right on top of a K complex. And it is also important to know that we cannot produce a K complex in REM sleep. We don't have K complexes in REM sleep by playing any sound or any other stimulus. But what is exactly a K complex and what functions might it have? Some people argue that a K complex shows that a person has a small arousal. Small arousal. This is one theory, but others argue actually the opposite, that the K complex actually protects sleep. It has a protection ability, protection function. Well, first of all, we have to see which of these ideas might seem more correct. Well, the idea is that since we say a K complex marks the transition into a deeper stage of sleep, as you might remember, when we see a K complex, we are actually transitioning from N1 to N2 of sleep. So this is a transition to a deeper stage of sleep. And this actually supports the idea of a sleep protective function. Please, my friends, in addition, the more K complexes we see, the deeper the sleep will be. So another interesting point is that if someone does not sleep for one night and the next night they finally sleep, they produce more and larger K complexes compared to previous nights when they slept normally. And this is another reason why many believe that the K complex supports the sleep protection theory. Please, my friends, now that we know what a K complex is, let's see where it actually comes from. We said that K complexes help protect sleep and that more of them usually means deeper sleep. But how this wave is created, what is happening inside the brain that makes this big positive, negative positive shape on the surface EEG? To understand this, please, let's us look at the surface here. All right. Please, my friends, when we look at the surface EEG, suppose it is the skull of a person, and here we have a K complex happening, and beneath the surface we have some neurons which are called pyramidal neurons. These are pyramidal neurons in the cortex, specifically in the frontal regions. We have lots of happy pyramidal neurons. Pyramidal. So let's suppose that we start with the surface EEG and then go down into the cortex to see where these shapes come from. Please, my friends, during the first part of the K complex, let's consider this is the first part of the K complex. We have a large group of pyramidal neurons that inhibit. It means that they hyperpolarize, which shows the downward part of the K complex on the scalp. And many of these neurons start firing. So during this phase of the K complex, we see neurons start firing. These are spikes that I am showing. So we have lots of spikes. And it means that a large group of pyramidal cells suddenly depolarize together and they have action potentials. So for example, if we record activity from these neurons, we can see that we have hyperpolarization here, but depolarization at the peak, at the positive phase of the K complex. They have lots of spikes here underneath. So this is the activation of thousands of cortical neurons that first are silent and then they start firing together. Please, my friends, this was a quick but a rather complete look at the K-complex. What it looks like on the EEG, where it comes from, in the cortex, why it appears, and what it might tell us about sleep depth and sleep protection. So we now understand it very well. It's time to move on to the next important wave of deep sleep, which is slow waves. They are closely related to K-complexes, but they appear much more regularly and form the backbone of entry sleep. In the next video, we're going to explore what slow waves are, how they behave. Thank you.